Hello everyone. Today we will start with a bare bones Mathematica primer. We will give some basic commands for calculations and plots, and you can find a larger set of useful commands and examples in the links below. Okay, so the first step is to start Mathematica, and you will find a notebook, a window called Untitled 1, and then you can switch the background by going here to Format and Style Sheet and choosing Reverse Color. You can switch between black or white. And then to make this palette over here show up, you can go to Palettes, Other, and Basic Math Input. And that will show this palette with useful symbols and shortcuts that we can use later. Okay, so once you start Mathematica, you will be in the input command mode. If you type any Mathematica command in this window, you can execute it using Shift and Return. You have to pay special attention with syntax. For example, you should type parentheses or square bracket or a curly bracket. These will all be interpreted differently. If you want to evaluate, let's say, the sign of x, the way to do it in Mathematica is to type capital S and then sign, and then the argument in square brackets, like this. And then if you press Shift and Return, or if you press the Enter key on your numerical keypad, Mathematica will evaluate this expression. In this case, it just evaluates to a symbol. You have to be careful to write the functions in this way. So all Mathematica functions start with a capital S or a capital letter. If you type sign with a small s, it will not be recognized. If you type sign of x using parentheses, like you do it in mathematics, it will not be recognized. So you have to be careful with your syntax. After typing in your Mathematica command, you can press Shift Return or the key Enter on your numerical keypad on the right side of your keyboard. That means Shift Return means pressing the Shift and Return keys simultaneously. After the output is displayed, you may type another input command and then press Shift Return again and continue the session on this way. If instead of working with one command at a time, you wish to set up a series of commands, you can type them sequentially, pressing Return after each one. Mathematica will not evaluate these commands until you press Shift Return or Enter, at which time the entire block of commands will be sequentially evaluated. You may always use the explicit asterisk symbol for multiplication. For example, let's suppose you want to calculate the product A times X. You can explicitly use an asterisk here and then press Enter or Shift Return to evaluate this. Or you can just type A space X, and that will evaluate the same expression. You have to be a little careful. If you type AX and you don't have a space between A and X, then this will be interpreted as one symbol, one parameter, AX. The exception is if you start with a number, let's say you want to evaluate 2x, then you don't need a space between 2 and x. Mathematica knows that this is 2 times x. It's a good idea to use the star symbol for multiplication always until you become proficient in Mathematica and you're sure that your syntax is correct. A common error that users of Mathematica run into occurs when they attempt to plot an expression that is not real or has no numerical value because it was either not defined properly or the quantities within the expression do not have specific numerical values. As an example, suppose that you try to plot an expression that you have called f, and it depends on the variable x. But the expression for f contains another quantity a, so that has not been given a numerical value. So, for example, let's consider f equals sine of x plus a times cosine of x. I can press enter, so Mathematica takes this as a definition of f, and then I can try the command plot the function f, and then with curly brackets I'm specifying the interval. We're plotting with respect to x from 0 to 10, let's say. So this is the Mathematica plot command. If I do it for this function f, I will get nothing because Mathematica doesn't know what a is. It doesn't have any numerical value. It's a symbol. So it cannot possibly plot it. To fix that, you have to specify a value for a before you use the plot command. So let's go back here and say a equals 2, and then try plotting again, and then you get a plot for this function. Okay, so let's talk about cells. Your output cell will appear here as output below your input line. These cells are denoted by these trackers here that are blue or gray on the right of the screen. The output cell will be grouped with your input command cell inside an outer cell bracket, signifying the entire cell group. You can select any cell by clicking on the cell bracket with the mouse. To correct the previous calculation, you can type your corrections in the command, click on the cell bracket and press Shift Return. The new output will then overwrite the previous output. Alternatively, instead of selecting the cell bracket, you can just click on any point in the cell containing the command lines. You can delete any cell or cell group by selecting this cell and then hitting the delete key, and that would get rid of that cell. You can close or open a group of cells by going here and double clicking. That will close the cells and hide the output. You can double click on it again and it will show the output. To merge a few cells, you can select them by dragging the mouse over them and then right click and say merge cells, and that will group them together, which means I can execute the whole group of cells, the whole cell, the whole group of commands with a single Shift Return command or right Enter command, like this. Okay, the basic input palette is useful for entering symbols. So for example, I can use pi here, which is the symbol for pi, or I can use e, the Euler constant. I can define it like this. Another way to introduce these constants without the palette is to use pi for p and capital E for the Euler constant. And these symbols are reserved, so I cannot use E to name any variable because it's reserved for the Euler constant. If you want to get the numerical values of this constant, you can type n, square brackets, and then let's say pi, and then hit enter, and you will get the numerical value of pi. If you want to see that with more digits of accuracy, you can type n pi and then the number of digits. Let's say I want 16 digits. Then Mathematica will give me 16 digits. If I want more digits, I can just type whatever number of digits I want in here, and Mathematica will give me this constant to the desired accuracy. And you can do the same thing for the Euler constant and get it to any accuracy you want. Now, if you want to use to type some Greek letters, you can use the palette, so alpha, beta, and so on. Or you can press the escape key and then G. That will bring you a menu. That will bring up a menu where you can select the Greek gamma. You can press escape and then capital G, and then you have the option to select the capital gamma, and so on. Otherwise, you can use a Greek keyboard, or you can use these letters from the palette to do the same thing. Okay, now let's talk about some examples of calculations and plots. So let's define a function. As I said, let's define a function that depends on a sign. Let's call it f sine of 10x times the exponential of minus x. So this hat here is used to define the exponential, and I can press shift return or the right enter key, and I have defined the function f. Now if I want to plot that function, I just showed the command earlier. It's plot and then f with x from 0 to 3. Hit enter and you get the plot. You can change that. Let's suppose I want to do the same thing, plot from 0 to 5. What you notice now is that some of the function values are outside the range of the y-axis. So to fix that, you can use the command plot range and then right arrow and then all, and then hit enter, and that will ensure that your function is entirely within the plotted range. It is often desirable to label the plot axis. So to do that, you can use the command axis label. So axis label, right arrow, and then first the x-axis, and then the y-axis. So these are the names. You can put other names of the axis, whatever labels you want here. And hit enter, and then you will have X and Y showing up here. You can also introduce a plot label where you can name what you're plotting. So I can say plot label here, and then I can use quotes to put some text in there, and I can say I'm plotting f equals the exponential of minus x times sine of 10x, and this is just ordinary mathematical or text notation. Whatever is within those quotes is treated as plain text. And I hit enter, and now my plot has a label in it. Okay, so now let's try some other commands, some symbolical commands. So let's suppose I want to calculate an integral of x, of f of x with respect to x. To do that, I can use the command integrate. So I want to integrate f with respect to x from 0 to b, where b is some unspecified parameter. And if I do that and hit enter, Mathematica will calculate this integral analytically and will give me the result. Now, let's suppose I want to evaluate this result for a specific value of b. One way to do it is to use a replacement rule. So replacement rules means let's define a new quantity y, which is z with b replaced by 1. So slash dot means replace all. If you hover over this, Mathematica will tell you what this does, and you can click the I button here to get more information on the documentation. Okay, so if I do that and hit the right enter key or shift return, Mathematica will go in and substitute b with 1 and evaluate this expression. It will evaluate z for b equals 1. And let's suppose I want to evaluate this expression numerically. I can say n of z or n of y actually, and that will give me the numerical value of this quantity. By the way, you can calculate the same integral numerically by using Mathematica's n-integrate function. This uses numerical techniques to calculate the integral. So let's suppose I want to calculate the integral of f from with respect to x from 0 to 1. You have to be careful that your function has to be completely specified numerically here before you calculate the numerical integral. If it's a symbol, if there's this unspecified symbol in it like b, it will not be able to calculate it numerically. It can only calculate these quantities analytically, right, or symbolically. Okay, so if I calculate this, then I get the same result as the one I got before by replacing a numerical value into the exact integral. And here's an example using the palette. You can click on this symbol here and you can fill in the numbers in usual mathematical notation. Integral from 0 to b of f dx and hit enter, and that will do the same thing as what we did up here. It just calculates this integral analytically. Now you can evaluate this integral for a certain value b like before, or you can use the % command, where % means the last output. So the last output is output 34. So I can use % and then slash dot and then replacement of b, replace b by 1. And then that will take this expression and replace b with 1. And if I evaluate this by hitting enter, I get the same result that I got earlier. So that's another way to do the same thing. Now let's suppose I want to evaluate this integral knowing what b is in advance. I can calculate from 0 to 1, and the integrand is f, and I'm integrating with respect to x. Hit enter and you get the same result. And let's suppose you want to check if this result and this result are the same. You can compare those by using an equals sign. So actually you can use % for the last output, equals, and then % is the previous output. So % is output 36 and double % is output 35. And to compare if these are equal to each other, you can use the equals command and hit enter, and Mathematica will compare them and return true if this is true, which it is. Or you could calculate their difference and see if the difference is 0. Okay, so now let's talk about functions and tables and their plots. So instead of defining an expression such as f equals sine of 10x e to the minus x, as we did here, it's more wise to define this function using an argument. Because if I define f like this, then f is simply this quantity. But if I want to evaluate f with respect to some other argument, I cannot do it. F is defined with respect to x if I define it in this way. So the proper way to define x, the proper syntax, is to use f of x and then underscore. And that underscore simply means that x is the argument of that function. And then I can use equals, or I can use delayed equals. So this symbol is a delayed equality, which means that this function will be evaluated later when I call the function. It will not be evaluated right now when I define the function. So let's suppose the function is again the same as before, sine of 10x times e to the minus x. Okay, so now I have defined this function f. So this construction makes the user-defined function f of x act exactly as a Mathematica built-in function, such as sine of x, in that if you call f of x repeatedly with different numerical or symbolic values of x, then f of x will be evaluated afresh each time. So let's suppose I want to evaluate f of y. Mathematica will simply, actually I made a mistake here. Y is a symbol I have defined earlier. So actually that's a good opportunity to tell you how to clear symbols. So one way to clear quantities that you have defined before is to use clear and then y, and then I can evaluate f of y, and it would just evaluate this function with substituting the argument x for y. And another way to clear, I have also defined the quantity z. Another way to clear this is to say z equals dot, and then you'll see that the color of the quantity changed here. That means the quantity is no longer defined, so I can use z as any symbol, and then I can ask for f of z, and it will plug in the symbol z in the argument of the function f instead of z, the quantity that I had introduced before. So setting z equals dot has cleared this definition, the previous definitions of z. Okay. Now in the following commands, let's plot the function f of x. So I can say plot, and then the function I want to plot, and then the argument I'm plotting respect to x from 0 to 3, and then close the curly brackets, close the square brackets, and hit enter, and that will plot the function. Now there's another important command called list plot, which allows you to plot lists basically, or tables of data. So let's create such a table of data. So let's call this my list, and let's create some pairs of x and y values. So a very useful command to do this is the table command, and we can use curly brackets to construct lists. We will talk more about lists later, but for now let's suppose we want pairs of x and f of x, and we want to construct a table for various values of x. So the iterator in this table is x, and I want to start from 0 and go up to 3, and I want to do it in steps of 0.1. So I'm closing this curly bracket, and then I have to close this square bracket, and then I hit enter, and this will give me a list of pairs of values for x and f of x. So x equals 0, x equals 0.1, 0.2, and so on, and the respective values of f of x for each of those coordinates x. Now, to see what this list looks like in a matrix form or a table form, you can say my list, and then you can say / table form, and then you'll see those pairs in column format. So essentially this is a matrix with 2 columns and several rows. I could also type table form, and then the argument is my list, and do it like this, and that will do the same thing. And another way to construct this list of pairs of x and f of x, let's construct first a list of the x values only. So let's call it capital X, and it's a table that takes x from 0 to 3 in steps of 0.1. So this is, I've made a mistake here. I forgot to put the argument here. Okay. So x goes from 0 to 3 in steps of 0.1. So these are my abscissas, or my x grid points. Now, because f of x consists of simple functions like sine and e of minus e to the minus x, these are listable functions, which means you can apply this function directly to a list, and Mathematica will return a list of the function values for each of those points. So now the question is, if I have a list of the x points and a list of the f of x points, how can I combine them into a bunch of pairs? So if I were to do this, well, basically you could do it like with a table command before, but I'm trying to do it in a different way that doesn't involve the table command, and that can be more efficiently evaluated, as we'll see in the future. So I could do this, but the problem is that this is not a list of pairs. So actually, if you use the dimensions command here, you'll see that this is a matrix of size 2 by 31, and you could use a table form to see that, or you can use the command matrix form, and now it looks like a matrix. So in order for Mathematica to do a list plot, it has to be in this format. It has to be a list of pairs, basically. So to do that, essentially what we need to do is take this matrix and transpose it. So if I just take this matrix and say transpose, now I get a list of pairs, and you can check that using the dimensions command. Now this matrix is 31 by 2, just like what I see here. And if you use matrix form, you can see that it looks like this. Or you can use table form, and you see that it has the right format. So now I can call this, let's call this my list 2. It has the right format, and now I can do list plot and say my list 2, and this will plot the data, these data points, which are pairs of x and y. This list is identical to the list I constructed earlier, which was called my list when I constructed it explicitly using a table command. So if I plot the first list that I constructed, I get the exact same result. Okay, now this data looks a bit scattered, so let's suppose I want these lines to be joined, these data points to be joined. So I can say joined, and then arrow, and then true. Okay, and then hit enter. and that will join these data points. Now, let's suppose I want to join these data points, but also show the data points at the same time. Then I can say list plot, and then my list, and my list again. So that will plot two kinds of data on the same plot. So then I can say joined, and then the first time I can say true, and then the second time I can say false. So I'm doing two plots at the same time and combining them now. And you see the result here. Okay. Now let's construct another list called my list. Let's call it my list 3, and that will consist of let's use the table command again to show it once more. It will consist of the values of the data points for x and f of x, and let's make it a bit more dense this time. So x will go from 0 to 3 again, but we'll do that in steps of 0.02. So there's a list of more points, and now I can say list plot my list 3, and that will show the points a bit more densely. And I can say joined true, and that will look a little bit smoother. There's also a way to smooth out the plot here. You can look it up in the documentation for the list plot command. If you want to look up documentation for some function, one way to do is to type information. That's a very useful command. And then list plot, and that will bring up some information on what this function does and how to handle it. And then you can click here for local documentation from Mathematica. You can click here for information on the web, or you can go here to help and then Wolfram documentation, and then just type list plot. I misspelled it, but it found it, and it will show information how to call this function, what arguments and what options there are to use. Okay, so let's consider another example. So let's suppose I want to create a function with two arguments called g of x. That's the first argument, and c is the second argument, and then delayed equality and a sine of c times x divided by x, and then hit the shift return or the enter key. So now I have defined g. And let's suppose I want to plot this for two different values of the parameter c. So let's call this my plot 1, and that will plot the function g of x, for a parameter c equals to 1. And we'll take the parameter, the argument x to go from -10 to 10. Then, because I want to plot two different parameters, plot this function for two different values of the parameter c, I'm going to choose two different colors. So I can specify the colors using the plot style command. So I can say red or blue, or you can use the RGB values. So let's say RGB color, and then say 0, 0, 1, and then I can say plot range all. And let's plot this. So red RGB is red, green, blue. So 0, 0, 1 corresponds to blue. Okay, so now let's copy paste this expression and define another plot, my plot 2, and let's plot this for another value of the parameter c. Let's plot it for c equals 2. And let's suppose I want to make this red, so that would be 1, 0, 0. And now let's suppose I want to combine these two plots together. You can do that using show, and then the argument of the show command is the plots you want to combine together. So my plot 1 and then my plot 2, and then hit enter, and then you get a plot with the two graphs combined. Now, of course, the last plot could have also been obtained by the general method of plotting two different functions in one plot by simply entering plot and then g of x for the parameter c equals 1, and then again g of x for the parameter 2, and then close the curly brackets. So that's a list of functions you want to plot, and then specify the argument x to go from -10 to 10, and then the plot style, you could say RGB color. You can click here to choose a color if you want, but we will do it the same way as before, 0, 0, 1, and then RGB color 1, 0, 0, and then close the curly brackets. So each of those functions will be plotted with each of these colors, and then plot range all, and close the square brackets now, and then hit enter, and that will do the same thing. Plot these functions together. You could also use blue here and use red here. That would do the same thing. And that's true in Mathematica version 6 or later. You can do that. Okay, so now let's move on to something different. Let's talk about series expansions. So a very useful command for symbolic operations is the series command. So that creates a power series expansion of a given expression. The command series of f with respect to x it's a series about x0, and it goes up to some order n. So what that command does is that it gives you a power series expansion for f as a function of x about the point x equals x0 up to terms of order x minus x0 to the nth power. If I type information of series, that's what the mathematical documentation will tell me. So, for example, I can type series of sine of x and then specify that I want to expand with respect to x and expand about 0. So it's a Taylor series. And I want terms up to 5th order in x. So you close the curly brackets, close the square brackets, hit enter, and Mathematica will give you this expansion. Now you can graphically compare this series expansion and the exact expression for sine of x to verify that the expansion is a very good approximation for small values of x. The expression for the series expansion in the argument of the following plot command will be made by copying and pasting these values. It's one way to do it. You can try and copy this part, or you can say // and then normal, and that will get rid of this order x to some power term. If you try to plot this quantity, you will get an error because this is a symbol, this is not a number, so Mathematica will not be able to plot this quantity. So you can use // normal. That will create that to a normal symbolic expression. And then let's call this f series of x. So that's one function, and then I have already defined a function f of x before, but this will overwrite it. And this is my other function, f of x. And now let's suppose I want to plot these together. So I can say plot, and then the first function is sine of x or f of x. And then the second function I want to plot is its series expansion, which is fs of x. Close the curly brackets, and then let's do the plot with respect to x from 0 to 4. And then choose plot style. Let's say the first one is blue, the second is red, and close this and try it, and we see that's blue is obviously the plot of sine of x, and red is the Taylor expansion, and you see that for small values of x, indeed these are very close to each other, and as the value of x increases, the Taylor expansion is no longer convergent, so it's no longer a good approximation of sine of x for larger values of x. Okay, so now let's talk about solving equations. So another very useful command is the solve command for solving equations. So let's type information solve. So using solve of some expression or some equations for some variables, we'll attempt to solve the system of equations listed here for the variables that you specify here. So let's consider a simple example. First of all, we can use clear all to clear everything we've defined so far. So we can use our expressions for x and y without worrying. Okay, so let's consider a system of equations. Let's consider a system of linear equations. X equals a plus by, and y equals c plus dx. Now notice I've made some mistakes here. So by would be treated as one symbol by Mathematica if I don't leave a space, or if I don't put a star there. So I have to put a space here. And the same applies for dx. I have to put a space here. So now Mathematica knows that this is d times x. And notice that when I'm solving equations, I have to use equals equals. If I use a simple equals, then Mathematica will simply treat this as a equality, and it will set x equal to a plus by. I see that a has another color here, so let's check what a is. So a has a value 2, so it wasn't cleared. So to clear that, I'm going to use a equals dot. That should clear the value of a, and now I'm able to use it as a symbol. Okay, so after making sure we've cleared all the variables we're using here, you'll see that they show up in blue. So none of them are defined to be something else. So these are my equations, and then my unknowns is, my list of unknowns is x and y. And then I ask Mathematica to solve. And let me go and delete this cell. To delete the cell again, you can click here and then hit the delete key. Okay, so I executed this command and Mathematica solved the linear system with respect to x and y. Now again, notice that I have to use the symbol equals equals here and here, so that Mathematica knows that these are equations, they're not equalities. So it should not assign a plus by to be equal to x. It should actually solve that equation as an equation. So note that the solution is expressed in a strange looking list with nested parentheses and arrows. This is essentially a list of replacement rules for x and y in order for you to replace x and y by their solutions. If you need explicit expressions for the solutions for further calculations, there are several ways to do it. One way to do it is you could simply copy Control C or Command C and Control V or Command V. You could copy paste these expressions, or you could name this my sol, let's say my solution, and then I can pick up elements from that list. So I can say my sol, and then I can say I want the first element. Let's see what that will give me. That will give me the first element of that list, the first row of the first column. and let's suppose I want to pick up this quantity without the x arrow. So one way to do this is to say x slash dot. This is a replacement rule, right? So it will take x and then replace it with this, because it will use x arrow this expression here. So if I do that, it will simply replace x by the solution. Another way to do it is to say mysol 1 1 1 and then comma 2. That will treat this as an inner list, and it will pick up the second part of that list. So I can say this is the x solution, and if I want y, then I can use y solution, and then it will again go to the first row, second column, and again we want to pick up the second element from this expression. So again, let's try this command that will give us y with a replacement rule. We want y itself without the y and the arrow. We just want the value of y itself. So to do that, we use comma 2, and that picks up the solution. So we can set that equal to y solution. Okay, as seen from the previous two commands, the syntax rule for extracting elements of lists involves nested square brackets with a number within these brackets specifying the location of the desired element within the list. Now let's check that our solution is correct by substituting x solution and y solution into these equations. So to do that, let's write down this equation. I copied and pasted it here, and I can type x solution here and b solution here. And I can simply evaluate this with equals equals. Mathematica should return true. But it will do that only after it simplifies and does some mathematical operations here. So let's try simplify. Let's try this command. So now it did some simplifications, cancellations, and it found that this is indeed true. Another way to do that would have been to calculate the difference, x sol minus a plus b y sol. And again, it finds some expression. It doesn't automatically simplify it. You can use simplify, and then it will do the necessary cancellations and find that the difference is 0, so that the first equation is satisfied. And you can do the same thing for the other expression. Let's say y minus c plus dx, and replace y by y sol and x by x sol. And if you do this, you get some result here, but it's not simplified. And then you can use simplify, and you can check that the result is 0. You can also apply simplify like this. Any function can be applied like that, or with slash slash. So I can also say simplify and then the expression inside these arguments. We remark that this technique can be used to test whether any two algebraic quantities are equal. for example, to determine if some expression A is equal to another expression B, you can say simplify and then A minus B, and see whether Mathematica returns the result 0. Sometimes if the expression is very complicated, you may have to do more simplifications. You can use the command full simplify A minus B. That will take more time, but it will try more simplification rules to calculate the result. And of course you can also try A equals B to check if two expressions are equal to each other, but you may have to simplify those expressions before you can make such a comparison. Okay, and some final comments about Mathematica. You need to be careful in defining expressions and in using the correct values of variables in these expressions. Errors may occur if the value of a variable is changed during the course of a session and you subsequently evaluate an expression containing that variable without realizing that the value of the variable has changed. Should be especially mindful of this if you decide to undertake the potentially dangerous action of scrolling back to an earlier command and re-entering the command after values of various variables have changed since the command was originally entered. When an expression is defined by a command such as, let's say, f equals sine of 10, f equals sine of 10x e to the minus x, the quantity on the left hand side of the equal sign, the quantity f here, is immediately assigned this expression. That's on the right hand side of the equal sign. It is essential that x has not been given a specific value before this definition is entered. If x has a value before this definition is entered, then f will not longer be given this function value. It will just be given whatever value of x you have, it will be substituted in here. So if x equals 3 and I say I want f to be 10x e to the minus x, then Mathematica will assume that x is 3, and when you evaluate f, it will be simply a number, not a function. So you have to be careful with that. So now let's set x equals dot. That will clear the value of x. Now I can use it to define this function, f of x. In the session shown above, x was not assigned any value before the definition was entered, and so there was no error when I defined f. And as a precaution, you can use x equals dot, or you can use clear x to clear a variable before you can use it to make sure that it's available. And you will see that its color changes to blue when it hasn't been defined and to have a specific value. Wherever you're in doubt on the current meaning or value of a symbol, you can enter it by itself and see what Mathematica returns as its value. So if I type x and then hit shift return or enter, then I get x. Then I know Mathematica hasn't assigned a value to x. Or I can try this for z or for y and so on. If you see that the color of that variable changes to white or black, or if you see, or if you just type it and hit enter and see some number or some other expression instead of what you typed, then you know Mathematica has assumed a certain value for this quantity, and you have to be careful using it. If you want to clear all variables, you can use this command, clear, and then global and then star. And that will clear all variables. So now even the x sol and y sol that I had typed earlier have been clear. If I type x sol now, it doesn't have a value. Okay, so that's it for today. For more information on defining expressions and functions, and for more useful commands, you can click on the links below. Thank you.